Welcome to lectures on instrumentation in process industries. So we are discussing the working of iron and steel plant. In the previous class, we have discussed layout of iron and steel plant, in which total 5 functional units we have discussed. That is iron making and steel making. In the steel making, we have 4 subsections processing units. In the iron making, only making of pig iron, which will be used as input material for the steel making. So, in that, we have discussed different types of steels and units in ISP, and the raw materials preparation in the ISP we have discussed. In today's class, we discuss different types of furnaces used in iron and steel plant, and a blast furnace working and making of raw steel, and working of basic oxygen furnace with a diagram, and electric arc furnace with a diagram we discussed today. And after that, what is the measurement and instrumentation involved in iron and steel plant, we'll see. That is the measurement of molten metal level and density, temperature, flow, weight and thickness of steel products we'll discuss. So these are the main processes we have discussed. The main processes here, that is iron making. Next, this is all steel making. Is all steel making. In the steel making process, we find basic oxygen furnace and casting and rolling and finished products we have. So these are the different processing units in iron and steel plant. Now let us see different types of furnaces used in iron and steel plant. We have blast furnace and basic oxygen furnace, electric arc furnace, ladle furnace. So this blast furnace will produce pig iron by taking raw materials. It produces the pig iron. And basic oxygen furnace, this will take pig iron as input material, pig iron. So this pig iron, it will convert it into steel item. And next, this is the electric arc furnace. This may take in both the cases, in steel making purpose, scrap steel, it will convert that scrap steel into molten steel. Molten steel means hot liquid steel. This is the molten steel. So from scrap we are getting the molten steel, and from basic oxygen furnace pig iron is changed to molten steel. So in both the cases. Next one is the ladle furnace, in which the ladle furnace with the molten steel plus alloys to get the desired steel grades. Different kinds of grades of steel can be produced with the ladle furnace. So these are the furnaces we will find. So the same furnaces let us see in the diagram also. So here this is a blast furnace. Blast furnace number 1, basic oxygen furnace, electric arc furnace. Only 3 furnaces are shown here, but actually if there are 4. Here if you observe, this is the basic oxygen furnace number 1. Number 2, this is the basic oxygen furnace number 2. Number 3, electric arc furnace. Number 4, ladle furnace. So total 4 furnaces are shown in this diagram. So now let us explain the working of blast furnace with a diagram. So this is the important furnace in iron making. Blast furnace is a metallurgical furnace used for smelting to produce industrial metals, generally pig iron, but also others such as lead or copper. These also can be produced. This blast furnace can be used to produce these items also. Blast refers to the combustion of air being forced or supplied above atmospheric pressure. So, above atmospheric pressure, if combustion air is supplied into the vessel, blast will occur. In a blast furnace, the coke will act as fuel. So the coke, iron ore and flux are continuously supplied through the top of the furnace, while a hot blast of air is blown into the lower section of. So iron ore, flax, fuel, coke are continuously supplied through the top of the furnace, while a hot blast of air, sometimes with oxygen enrichment, is blown into the lower section of the furnace through a series of pipes called tires, so that the chemical reactions take place throughout the furnace as the material falls downwards. You see, this is the blast furnace. So we are charging 3 raw materials, that is coke, iron ore, flux, and at the same time we are supplying hot air also, oxygen enriched hot air also we are supplying. So this is possible by fixing tires, series of tires like this. So hot oxygen mixed, oxygen high rich hot air is being supplied into the vessel. So what happens is blast will occur. So it produces high temperatures and pressure conditions in the vessel. So these three items are completely boiled in this. At the bottom, two liquids are developed because of these chemical reactions as these three items are coming down. So these are the tires we have. These are the tires that will supply air into the blast furnace. So this is the blast furnace. Observe here. Observe here. Three raw materials are coming from the top to bottom like this, in this way they come, and at the same time a series of tires here, these are the tires on both sides. These are the series of tires you will find here. These are supplying hot air, oxygen enriched hot air into the vessel. Because of this three items and hot air, what happens is explosion take place in the vessel. So that blast is because of the chemical reactions. You see the chemical reactions here. Reduction of iron ore at 700 degrees centigrade. At 850 degrees centigrade, as it comes down, 850 degrees centigrade temperature is there. At the top, 250 or 300 degrees centigrade is there. As you come down, the degree of centigrade temperature increases. So at this temperature, the slag is formed. How the slag is formed? CaCO3 with sulfide, you see, a solid form, and you have the solid and gas, solid and sand both are mixed. You see the slag how it is formed. This is all chemistry part. So the carbon dioxide will react with carbon. It produces carbon monoxide, the gas. And at 1500 degrees centigrade, we have, you see, carbon and oxygen, carbon dioxide, and at the same time, the molten metal also will form. So at the bottom, what you observe is, at the bottom, two liquids we will find. One liquid is slag, another liquid is pig iron. So this bottom liquid is called pig iron. So this pig iron is important. So pig iron forms at bottom, which is used for steel making. So this slag is used for other purposes, and now this is tapped and collected into a vessel, and this also molten iron is also collected, and it is sent to the steel making unit. And the hot gases that are produced are sent into environment like this. Hot gases, flue gases will escape like this. So this is the working of blast furnace, which is very important behind the heart of the iron making. So the iron making blast furnace itself is built in the form of a tall structure lined with refractory brick and profiled to allow for expansion of the charged materials as they heat during their descent, that is coming down during their coming down, and subsequent reduction in size as melting starts to occur. So coke, limestone flux, and iron ore, that is the iron oxide, are charged into the top of the furnace in a precise filling order, which helps control gas flow and the chemical reactions inside the furnace takes place. So as the raw materials are descent down, then the reactions take place, the chemical reactions take place, so that the molten iron and slag will form. This slag will collect the impurities present in the molten iron. You see, as the raw materials are descending from top to bottom, the refractory structure of this blast furnace vessel is such that its diameter increases as the materials comes down. The end products are usually molten metal and slag pieces tapped from the bottom. So these two are end products. So product one is slag, top one is the slag, bottom one is, this is the bottom, the bottom one is the pig iron. These two are the important products developed at the bottom of blast furnace. And those two metal, molten metals and slag, both both are collected into vessels, and waste gases, that is the flue gases, exiting from the top of the furnace. The downward flow of the iron ore and flux in contact with an upflow of hot carbon. So the downward flow of ore flux and upward flow of hot carbon monoxide rich combustion gases is a counter current exchange and chemical reactions process. So this is the counter current exchange, that is downward flow of materials, upward flow of gases. So this will take the counter current exchange, which will gives rise to chemical reaction that will take place in the blast furnace. You see, you see how the gases are formed, and these are the gases formed, and these are the materials and gases formed. So the gases flows like this, flows like this gases, and chemical, because of the chemical reactions, the total fluids, two types of fluids will develop at the bottom of the blast furnace. Modern larger blast furnaces may have as many as four tap holes and two cast houses. Once the pig iron and slag has been tapped, the tap hole is again plugged with refractory clay. That means once this is tapped, once the slag is tapped and molten pig iron is tapped, then what happens is with clay, refractory clay, once again it is fixed, closed. The hot blast temperature can be from 900 degrees centigrade to 1300 degrees centigrade, that is 1600 degree Fahrenheit to 2300 degree Fahrenheit, depending on the stove design and condition. The temperatures they deal with may be from 2000 degrees centigrade to 2300 degrees centigrade, that is 3600 degree Fahrenheit to 4200 degree Fahrenheit. Process of making raw steel. So the basic oxygen steel making is a method of primary steel making in which carbon rich molten pig iron is converted into steel. So to make raw steel, definitely we need pig iron as an input material, and the basic oxygen furnace will convert this pig iron into steel. So blowing oxygen through molten pig iron lowers the carbon content of the alloy and changes it into steel. That means minimizing the carbon content in the pig iron, then it will give us steel. If you add different uh, grade to get the different grades of steel, we have to add the different percentage of alloys to the pig iron. So the process is known as basic due to the chemical nature of the refractories, that is calcium oxide and magnesium oxide, that line the vessel to withstand that high temperature and corrosive nature of. So so the process is known as basic due to the chemical nature of the refractories, calcium oxide and magnesium oxide, that line the vessel to withstand the high temperature and corrosive nature of the molten metal and slag in the vessel. The slag chemistry of the process is also controlled to ensure that impurities such as silicon and phosphorus are removed from the metal. So the mainly there are two impurities, that is silicon here, silicon and phosphorus. So these should be removed and proper alloy is to be added so that the required grade of steel will be produced. So this is the basic oxygen furnace. A vessel is there. This is the vessel. This vessel is subjected to pig iron. Pig iron. So pig iron and oxygen. So this is the oxygen lancer through which oxygen is supplied at the bottom. And this is the uh, what happens is you will find steel is formed here at the bottom, required steel, and slag is formed upper part, and finally gases will release. So as the hot pig iron is coming down and oxygen is supplied through the lancer, then what happens is both will react here and slag will form on the top layer. This is the slag layer, and hot gases are produced, and this will flow up, and at the bottom you will find the required steel, molten steel. So the basic oxygen steel making, BOS, BOP, BOF or OSM, also known as Lynch-Donovich steelmaking, or the oxygen converter process, is a method of primary steelmaking in which carbon-rich molten pig iron is made into steel. So these many number of names you will find here. BOS, basic oxygen steel making, BOP, basic oxygen process, basic oxygen furnace. You see these many number of names you will find. Oxygen steel making, and Lynch Donovich steel making, because he invented this process. So this, using these methods, which is one, two, three, four, five names. So you can call with five names, and this is the basic converter which will convert the pig iron into required steel. So that is a now blowing oxygen through molten pig iron lowers the carbon content of the alloy and changes it into low carbon steel. So finally, the carbon is lowered and we will find a low carbon steel. So the process is known as basic because fluxes of burnt lime or dolomite, which are chemical bases, are added to promote the removal of impurities and protect the lining of the converter. So this is a very important point you have to remember. So that is fluxes, that is lime, and because of this, impurities are removed and converter is also protected. That is the advantage of fluxes. Are now let us see the working of oxygen furnace with a diagram. So the basic oxygen steel making is a primary steel making process for converting molten pig iron into steel by blowing oxygen through a lancer over the molten pig iron inside the converter. So exothermic heat is generated by the oxidation reactions during blowing. So because of this heat generation, what happens is slag is formed on the top layer and molten steel is formed at the bottom of the vessel. Observe here, there are two figures I have shown you. So this is both are same basic oxygen converters. You can learn this or this. So this is the lancer through which we are supplying oxygen, so that this oxygen lancer, because it is producing oxygen, what happens is this will react with molten pig iron, and hence there are two liquids formed, that is slag and iron, molten steel, slag and steel. This is the slag, this is the steel. So this vessel is the refractory structure which is protected one, and you can tap this slag outside and molten steel also you can tap it outside, and whatever the flue gases that are produced, fumes and flue gases will escape into environment like this. So the molten pig iron, sometimes referred to as hot metal from a blast furnace, is poured into a large refractory lined container called a ladle. The metal in the ladle is sent directly for basic oxygen steel making or to a pre-treatment stage. High purity oxygen at a pressure of 700 to 1000 kilopascals, that means 100 to 150 psi, is introduced at supersonic speed onto the surface of the iron bath through a water cooled lens which is suspended in the vessel and kept a few feet above the bath. That means the oxygen here, oxygen here, it is being supplied at high pressures, that is 100 to 150 psi. So this much pressure, with this much pressure, the oxygen is supplied into the surface of this pig iron bath which is available in the converter. And at the same time, the oxygen, not only the oxygen is supplied into the bath, at the same time the lancer is continuously being cooled down. So this lancer must be cooled down by circulating a water through this continuously, a cooling water, so that it will get cooled. So this is the provision there. So sometimes before it is subjected to converter, sometimes what happens is the pre-treatment of pig iron is done. So the pig iron is pre-treated before it is sent to basic oxygen furnace or ladle furnace. So that is possible that pre in the pre-treatment stage what happens is sulfur and phosphorus, silicon. So these are the unwanted impurities present in the pig iron which will be removed with the help of oxygen converter. So the slag here, if you observe here, the slag will collect these impurities. These impurities. That is the thing you have to remember. And after taking these impurities, the pure steel metal is available to us. So the pre-treatment of the blast furnace hot metal is done externally to reduce sulfur, silicon, phosphorus before charging the hot metal into the converter. In external desulfurizing pretreatment, a lance is lowered into the molten iron in the ladle and several hundred kilograms of powdered magnesium are added and sulfur impurities are reduced to magnesium sulfide in a violent exothermic reactions. So sometimes to remove the sulfur it is very difficult task to remove the sulfur. So for that a pre-treatment process is done to eliminate that impurity just by supplying thousands of magnesium powder with the help of lancer. If you supply that because of the exothermic reactions, so the magnesium will take away the sulfur with a reaction product magnesium sulfide. So with that it is somewhat possible. The sulfide is then raked off. Similar pre-treatments are possible for external desiliconization and external dephosphorization using mill scale, iron oxide, and lime as fluxes. The decision to pre-treat depends on the quality of the hot metal and the required final quality of the steel. So, these pre-treatment processes are considered based upon the required quality grade of the steel only. So, the pre-treatment processes can be carried out separately to remove the sulfur, silicon, and phosphorus. So, with the help of exothermic reactions in the Lance converter. So the BOS vessel is charged with steel or iron scrap. If required, molten iron from the ladle is added as required for the charge balance. So that means the iron scrap or steel scrap. So observe here 25 to 30% of the scrap, that is iron scrap or steel items scrap. So these are added into the ladle furnace. So this is to balance the, that is 70% is from this and 30% is from this. Both are 70% and 30%, total 100% is added into the ladle furnace. So into this so now because of the lancer, oxygen lancer, what happens is the oxygen is reacting with carbon and sulfur and phosphorus and silicon. So these are the elements present in the pig iron, molten steel. So these are the impurities. So we want to reduce the carbon content and we want to eliminate these three impurities so that we will get the required grade steel. For that, we are supplying oxygen with the help of lancer. So this oxygen react with phosphorus and silicon and sulfur and phosphorus oxide is eliminated. This is removed, and silicon dioxide is also formed and it is removed through slag. And next one is the sulfur content. Somewhat it is difficult with react. So a separate pre-treatment action is to be taken to eliminate this sulfur. So this is possible with the help of magnesium content. So magnesium, if it is supplied, then this magnesium will react with the sulfur and it will eliminate magnesium sulfide from the in the form of magnesium sulfide, uh, that will be eliminated. So finally, we will get the required grade steel. With this, we have discussed today we have discussed today the basic oxygen furnace, and that is one, and the ladle furnace we have discussed, and how the pig iron is used to convert it into the steel, molten steel we have discussed. So with this we conclude our lesson.